For this series of videos, we're going to stick to the trigonometry. And what we're going to do is we will work with the fact that we are given two sides and need to determine the angle theta. Once again, between the two shorter sides, there's going to be a 90-degree angle. So just to refresh your memory, you can see where the angle theta is going to sit. And the angle that will be right across it, or the short side right across it, will be known as the opposite. The short side right next to theta is going to be known as the adjacent. And then the longest of the three sides is going to be known as the hypotenuse. In my very first example, we have been given the hypotenuse as well as the opposite. My little rhyme says that some old horses can always hear their owners approach. In our case, what we want to go and do is we would like to go and determine the angle theta using the opposite and the hypotenuse. Now, if you look at my formulas at the bottom, the opposite and the hypotenuse are going to occur in association with the sine of theta. And therefore, we can go and say that the sine of theta is going to be the opposite over the hypotenuse. Now, we're trying to determine theta on its own, and therefore, it's going to be the inverse sine or the arc sine of the opposite over the hypotenuse, which is going to be the inverse sine of 4 divided by 5. And that will give me an answer of 53.15 degrees. And that would be our first calculation. For our second calculation, we have been given the adjacent as having a value of 3, and the hypotenuse is going to have a value of 5. So we look at the formulas at the bottom. Some old horses can always hear their owners approach. And we have a look at where the adjacent and the hypotenuse are going to occur together, and that certainly is going to be the cosine of theta. So straight away we can go and say that the cosine of theta is calculated as the adjacent over the hypotenuse, and that means that theta is going to be calculated as the inverse cosine of the adjacent over the hypotenuse, which is going to be the inverse cosine, and you just use that function on your calculator of 3 divided by 5, and that should give me an angle of 53.15 degrees, which happens to be exactly the same angle that we calculated in the previous example. And for my very last iteration, let's say that we've been given the value of the adjacent and we have been given the value of the opposite, and we would like to go and calculate what the value of theta is. We're working with the opposite and the adjacent, and the only formulas where that is going to come together is going to be with the tan of theta. So we can go and say that the tan of theta is going to be calculated as the opposite over the adjacent. Therefore, theta is going to be the arctan of the opposite over the adjacent, which is going to be the arctan of 4 divided by 3, and that's going to give me an angle of 53.15 degrees. Once again, we've got to exactly the same value. So whenever you are going to be given an angle as well as one of the sides, or whether you're going to be given two sides, it doesn't make a difference. You're going to use your trigonometry equations and you should be able to come up with the right answer. In this case, we've been given two sides and we've successfully calculated what the angle theta is going to be. And hopefully that has refreshed your memory. Please remember, practice, 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 and it's all going to fall into place.